What's up, everyone? We're live day two with the Geometry Regents review. And yeah, yesterday I had done questions 1 through 29. So I left off at question 29. So if anyone is interested in the first 29 questions of the June 2015 Regents exam, that's the one I'll be talking about. You could check out day one. It is saved on my channel. So, feel free to check that out. But for this particular one here, we're going to be starting at question 30 and moving on. So I'll give a little bit of time for people to join in. But yeah, thank you to everyone who supported yesterday. Good luck to everybody who is taking their Regents exams, not just in math. If you're taking Regents exams in any subject, or if anybody is in the middle of their finals week, I hope your finals are all going well. So yeah, this is what we will focus on. Oh, so at Ryan Tube, hello. I'm glad you stopped by to say hello. I'm always happy to hear from you. And yeah, I just remember you from last year. Even though what's nice about being on YouTube is, yeah, with this, the people who are supporting the channel and part of this, I like that now. Some of you, I recognize your usernames and I know your stories. But awesome work over the past summer, doing so well. If I remember correctly, I know you had done really well on Algebra 2 on that region. So awesome work. Yeah, if you, I'll give people time to join in and stuff. But what math are you taking now, Ryan Tube? Are you in pre-calculus, maybe AP pre-calculus or calculus? I'm just curious to see where people are at. Oh, only that's cool at 50K Lavish. I'm glad that your school is also doing a live stream. Um, but yeah, no, I started doing these live streams. This summer coming up will be my third live stream. So last year I did the live stream for the AP Calculus exams and the New York Regents exams for math for algebra, geometry, algebra 2. But the year before, I think I had only done geometry. I was very new to streaming, but it was the day before the Regents, and it was like a lot of fun, even though it was like definitely not my smoothest live stream. Um, so full I. You know what? Now you and Fortnite. The other very enthusiastic member of the community are now more than one person mentioning the full IB math. I have to really look into that. At Emily, hello, and yeah, hi, nice to see you. But yeah, the IB math. Now I really have to look into that now. That's what's nice about this community is that I'm learning things constantly about. The math. I'm sure like I'll probably recognize a portion of it. Having God, that was my major in college, being a math major. But it'll be nice to brush up and challenge myself to start instructing on some next level stuff. So it's exciting where the channel is taking me. There was an advanced math guy who commented on one of my newer calc videos who mentioned something about like a Dirac function. I might be saying it wrong, but it was like, wow, that's cool. That's something I never heard before. But it must be somebody doing like graduate level math. And it was just, yeah, I appreciate everybody that I'm meeting doing this. Failed your geometry region, so I got to redo it. Yay. Well, you know what? You just do your best. I know it's frustrating if you don't get it your first time, but it's all right. So Emily, yeah, I did do a live stream yesterday, and I have questions 1 through 29 in there. But I mean, I'm sure you'll get plenty out of this. Otherwise, I do have a walkthrough of the most recent geometry regions from start to finish, part ones, and then parts 2, 3s, and 4s. But the live stream is cool because I could interact with everybody in live time and connect. So thank you for being on and for supporting. So I guess I'll jump into question 30. So here we have, after a reflection over a line, triangle A prime, B prime, C prime is the image of triangle ABC. We have to explain why. So the actual question here is to explain why. And let me just get the pen tool to show up. Why triangle ABC is congruent to triangle A prime, B prime, C prime. All right, now the $1 million phrase with questions like this, and just be mindful that this is still the 2-point questions. Okay, so we don't really have to say like a ton here, but I still wind up writing a bunch. But when I reflect a triangle over a line, I'm gonna do my best to draw this the same, but the triangle is not gonna change. And the reason being is that a reflection, we say, is a rigid motion. Okay, a rigid motion is a transformation that preserves distance and angle measure. So I would just say that, okay? I would say a reflection So a reflection is a rigid motion. So using the vocabulary just really is like the best way to go here. So a reflection is a rigid motion. So then I would mention, so a reflection preserves. Okay, so preserves means keeps. Okay, like when they put preservatives in food, it's to keep it from spoiling. Okay, like McDonald's, you could have a French fry in your car for 10 years and I mean, I probably wouldn't eat it 10 years later, but it's going to look the same 10 years later. It probably won't decompose by then. Okay, or maybe it would. I don't know, but definitely like 3 months, it would be still looking the same. All right, so a reflection preserves distance and angle measure. Now, what that means is if the distance between the sides, when we reflect, so here, here, like these ones that are corresponding, that the side lengths are not going to change. So what I would say then, therefore, just know the 3 dots in math, you could write the word, but that means therefore. It's just a cool way to abbreviate. Okay, so therefore, I would say here that if I give them names, like let's say A, B, C, then this would be C prime, B prime, A prime. Remember, with the reflection, it goes equal distance to the reflection line, and then it goes the same distance across. So that would mean here that something like AB, line segment AB, would be congruent to A prime, B prime, this line segment. I could also say that BC is congruent to B prime, C prime. And finally, I could say that AC is congruent to A prime, C prime. All right, now think about what I just established. I just established that these 2 triangles have 3 pairs of congruent sides. So then I'll just sprinkle in one more therefore. Therefore, triangle ABC is congruent to triangle A prime, B prime, C prime by the side postulate. All right, I'll just say by SSS. All right, this is 2 points. So I imagine here, if we left this line out, like we'd probably be okay because it's 2 points. But we just have to mention like the big details, or that you mentioned that a reflection is a rigid motion, that it preserves distance and angle measure. Okay, so saying that is very important. I would say that's a must. All right, so, and then you could really just use any one of those postulates. You could have used side, angle, side, angle, side, angle. Don't use angle, side, side. That would be the donkey theorem. All right, excuse me. So, all right, let's see here. 31. So 31, there's a nice quote from Abraham Lincoln. I probably mentioned it yesterday. But you give me 6 hours to chop down a tree, and I'm going to spend 4 hours sharpening the axe. So this one, the idea is like, so I would say themes for this question or tips is, think, imagine. Those kind of mean the same thing, I guess. Imagine and like be patient. Okay, so like just really think about what this looks like. We have a flagpole cast a shadow. So a flagpole is going to go this way. So if I draw like a situation here, we have the ground, like there's the flagpole. Okay, and it's going to cast a shadow that's 16.6 meters long. Okay, so this whole space here is 16.60 meters. Tim stands at a distance 12.45 meters from the base of the flagpole. So the base means bottom. So here, notice that's the base. It means bottom. So this is just really being careful to think about this. And then once you think about this, it's not too terrible. So Tim is standing at a distance, so we'll change colors here, of 12 point, we'll say that's about here. Of this distance in red, I'll put 12.45 meters. Okay, he's standing 12.45 meters from the base of the flagpole, such that the end of Tim's shadow meets the end of the flagpole's shadow. And now we want to know how, if Tim is this tall, determine and state the height of the flagpole. Okay, so what I'm imagining for the rest of this question is, I'm going to do this. Okay, so this is like the distance here from the top of the flagpole down. And notice what shape we have. So here's Tim standing over here. So Tim is standing here like this. Remember, Tim is standing 12.45 meters away. He's standing here like this. We know that Tim is 1.65 meters tall. And we want to know what is the height of the flagpole. So I'll put an X here. Now, the concept, we're assuming, they should mention here, but we should assume that the flagpole is built well. It is not like the Leaning Tower of Pisa. Okay, so these are going to be right angles here. And what we have is, what I like to think of this as, we have a big right triangle. So we have a big triangle, and we have a little triangle. Okay, so the big triangle, this distance we call X, and this distance we call 16.60. This little triangle, see over here, is 1.65. And this bottom distance, I could just do 16.60 minus. Okay, so if I want to find this space here, once again, I could just do this minus this. And we'll go ahead and work this out. So let's see. So this works out to 4.15. So what that tells me is that this missing piece here is 4.15. Now, the reason why I like to do this is these two triangles, notice that they share this angle over here. So those two triangles are similar. So I like to separate the triangles because then setting up the proportion is going to be much easier to get. So now proportion, like the proportion we set up, we're going to have X over, and we have 16.60 equals, oh, I see the chat's lighting up here. So hello to the new people joining in here. I'm happy to have you all. So let's see, X over 16.60 equals 1.65 over 4.15. And let's fix that, 4.15. Okay, so then to solve for X, you could cross multiply, but notice that X is in the numerator. So I could just do this. I could just do times 16.60 on both sides. So I'm just multiplying, and now this cancels. And we'll have X equals. So X equals, and whoops, let me just set this up over here. So we have 1.65 times 16.6, and then divide by 4.15. So we get 6.6. Okay, so 6.6. So determinant state, the height of the flagpole to the nearest tenth. Make sure you're actually writing it the way they want. So 6.6 meters. All right, there's our answer. Very cool. All right. Whoops. Sorry. I got to get used to these controls again. A little out of practice. All right, so part 3 we graduate to. The 4-point questions. So these already are going to be like a little bit more work to show. All right, I really didn't like this question. I feel like they've evolved how they've made Regents, because this one, how do I feel about this question? I mean, look, you get 3 hours, so just suffer. But this question is more tedious than it is difficult. Okay, the reason I say it's tedious is they tell us here, we have a diagram, and they tell us GH is congruent to IH. So I'm already like, all right, this is isosceles. Then we have EGB, that's this angle here, is 50 degrees. So, we have DIG is 115. And from here, we have to explain why these lines are parallel. So I know it's going to be something to do with, like, let's say, either alternate interior angles being congruent implies the lines are parallel, or maybe corresponding angles. I could show that angle GHI is 50. So, like, I know the strategy I want to use, but the problem is if I just do this, if I just go, like, let's say, all right, 180 minus this is 65. And then this is isosceles. So this is 65, this is 65. And then I do minus 65 and 65 from 180, I get 50. And I'm like, oh, they're parallel. Like, it's like the math itself, I don't think is crazy. But the fact that we have to explain why is like, ugh, I have to write a lot of sentences. Okay, so I'm not going to put anything in there other than what they tell us first. So they told us GH is congruent to IH. They told us that this angle is 50 degrees. And they told us angle DIG is 115. And explain why those lines here. So we're trying to explain why, or these line segments are parallel. Okay, so this is what we're targeting. But I already outlined the strategy. So now we just have to be careful writing it all out because, like I said, it's just going to be more tedious than it is going to be difficult. So here, the first thing I would say is the measure of angle GIH. So this angle here. So the measure of angle GIH is equal to 180 degrees minus 115 degrees. And this is 65 degrees. All right, now why? We have to explain why at like every step. We could say because angle GIH and angle DIG are a linear pair. Okay, you could even say like form a linear pair, are a linear pair. You know, that's the one annoying thing about the Regents. Like, I would say if your language is close, they're not gonna like get out the magnifying glass and say, "Oh, well, you didn't say it exactly the way we like to hear it." Like, it's as long as you're like reasonably close. So we could say because this angle and this angle form a straight line, you could say, or are a linear pair. All right, so form a straight line. Okay, so that's more than enough. I would say that gets us at least 1 point, just doing that. But now, what I would say next is I would say how this triangle here, that triangle GHI, that we could say that this angle is also 65. All right, and let's see, like, how do we know that the measure of angle HGI is also 65? So the measure of angle HGI is also 65 degrees. And notice that we have two sides of this triangle are congruent. So the angles opposite of congruent sides are congruent, okay? So if you want to say a little bit more beforehand, you know, like say, maybe like before we mention this, if you really, really, really want to play it safe, you could say that triangle GHI is isosceles. Okay, and if you want to just mention like two sides are congruent. Okay, let me just make that neater. So two sides are congruent. Then we could say the measure of angle HGI equals 65 because in a triangle, I'll mention that in a triangle. So in a triangle, angles opposite of congruent sides are congruent. So angles opposite of congruent sides are congruent. You know, you could say, oh, and therefore equal in measure, but once again, they're not going to get too crazy here as long as you're like explaining your reasoning. Now, the next thing we have is a triangle here. And notice this triangle, that this missing angle we could find by subtracting the sum of these two from 180. So now I could say that the measure, so this one here is going to be 50. The measure of angle GHI is equal to, we'll have 180 minus the sum of the other two angles. So this one here is going to be 50 degrees. And we could say because the sum of the three interior angles of any triangle is 180 degrees. So now I have to shrink this. We're officially running out of space. Oh no. All right, so let me group this and shrink it down. Okay, so let's now go back to writing. So because the sum of the three angles, the three interior angles, I'll be specific, of a triangle is 180 degrees. Okay, but now think about what we just established. We just established that this angle here and this angle here are congruent. So now there's a nice theorem that we could use that says that if corresponding angles are congruent, okay, so the corresponding angles formed by these two lines cut by a transversal are congruent, that means that the two lines involved are parallel. Okay, so Now I'll just summarize all this and just write it as carefully as possible. But as long as you get the idea down, they're going to be pretty forgiving. So I'll say AB, line segment AB, is parallel to line segment CD. Now, it might be better to start with this or end with this. So I kind of think about the sentence. That's the sharpening the axe part I talked about before. You really just think about what you're about to put down on paper. So here, I would say these line segments are parallel because the corresponding angles formed by these two lines being cut by a transversal are congruent. I could probably, I can just get away with saying this because the corresponding angles, so the corresponding angles formed by AB and CD being cut by, and what's the name of that line segment? EF. So EF, yeah, so the EF is the transversal. So the corresponding angles formed by AB and CD being cut by transversal EF are congruent. Okay, so this is the $1 million phrase right here. Because the corresponding angles formed are congruent. This is all extra by AB and CD being cut by transversal EF. Okay, so that's how I know that the $1 million statement here is that the line segments are parallel. All right, like I said, tedious. All right, that's one of those questions like when I have to write it out, I'm just like, all right, here we go. I don't know, I'm like more a fan of the exciting questions that there's more nuance to them. So question 33, we have this nice quadrilateral. We're told that it's a parallelogram. And we have diagonals AC and BD intersect at E. And we want to prove that, let's see, triangle AED, that's this triangle here, is congruent to triangle CEB. Okay, so those are the triangles that we're targeting. So I just like to think about that. Now, for these kind of proofs, I'm just going to go statement reason. All right, and these, once again, are somewhat tedious. I mean, that tells us then that the 6-point question is not going to be a triangle proof. So it could be a 4-pointer or a 6-pointer. The 6-point ones usually involve, other quadrilaterals. They're a little bit more complicated. So this part here you have to do, but you get no points for doing this. So quadrilateral ABCD. So ABCD is a parallelogram. And look, one thing to point out, it's a little bit of effort. They're not going to grade you if you spell parallelogram wrong. However, if they write parallelogram like in the question, like do your best to just copy the spelling. All right. When I see spelling errors and like the word is there, it's like a little bit like, come on, like, just put a little effort. But if you do a terrible job spelling it, like they're not going to dock points. This is not the English Regents. So don't worry, you'll still be okay. But I don't know. It's definitely like one of those things like where just I guess that happens because students don't read carefully. Maybe they're feeling like, stressed out. They're in the middle of a test. They're not really too concerned about spelling. But all right, so this one is true because it's given. So the given, once again, gets you no points, but you have to put it like in the question. Oh, at Chris, watched June 2022. Oh wow! Thank you for being and you passed with 85 and up. I'm happy that you're on have joined us, Chris, to say hello. Yeah, it does make me really happy knowing that I got people from like 2 years ago stopping by. You're always, remember, anyone here, you are always welcome to come back and say hello. I'm always happy to have like my former students come on. So, oh yeah, Chris, I guess that would mean like maybe you are taking pre-calc now. Yeah, let me know in the chat what people are up to, what math you're taking. But like I said, I should have mentioned at the beginning of this live stream, of course, everybody is welcome. The more the merrier, and consider spreading the word if you have classmates that your friends that are taking this Regents, and you think they could benefit from the live stream. You could always shoot them a text. Okay, so strategy. When am I going to show? Oh, when am I going to live stream for Algebra 1? Tomorrow. I'm going to live stream Algebra 1 tomorrow. Okay. I am using which Regents? Because I already did it. But I'm doing June 2015 tomorrow. Okay, so tomorrow. Let me not write Tom. I don't know why. That's this. Yeah, let me not abbreviate. So tomorrow for Algebra 1. So move up. Yeah, something's going on with this like software. It's not writing as nicely as it used to. I'm doing Algebra 1 June 2015. I'm going really far back because I imagine like teachers didn't do those in class. Like they probably most likely did the most recent ones, so that's why I'm going far back. Okay, so back to this, proving these two triangles congruent. Well, we have a parallelogram. So I could say that these opposite sides here are congruent, and I could say that they're parallel. The reason why I want to mention that they're parallel is because, once again, if I'm targeting these two triangles, I have one pair of congruent sides, and then I could say that alternate interior angles formed by these parallel sides are congruent. So I could say that angle DAE is congruent to angle, let's say BCE over here. And I could say that this angle is congruent to this angle. And then you could see how it's shouting out angle side angle. Okay, so the strategy I want to use here is I want to use the angle side angle postulate. Okay, so first I could say that in one statement. I could say that AD is parallel to BC. Okay, and I could say that they are also congruent. Now, one thing here, I guess the order, I could say AD is congruent to CB like this, so that it's following the letter arrangement. They're not going to get too caught up on that, but if that bothers you, just follow the order. Then, like once again, the letter arrangement in the triangle tells you which angles are corresponding. So you see, like at A and at C, that's the first letter. These angles are marked off as the same. So if you want to say it that way, like AD is parallel to CB, and I could say AD is congruent to CB as well. And the reason this is true is we could say that in a parallelogram, so in a parallelogram, I'll just abbreviate, the opposite sides are congruent and parallel. Okay, that's parallel I'm putting here. What that just established so far is we have a pair of sides that are congruent. Now, next what I could say is I could mention the angles. I could say, and maybe I'll put numbers here. I could say like angle 1, 2, and then 3, 4. I could say that angle 1 is congruent to angle 3. The reason I'm doing this is because it's very annoying to write out the 3 letters. And I could say angle 2 is congruent to angle 4. And once again, we have alternate interior angles. But this, we have to write a little bit extra. This gets a little annoying. We have to say when parallel lines. Okay, so when parallel lines are cut by a transversal, so I'll write that over here, are cut by a transversal, the alternate, I'll abbreviate, interior angles formed. Yeah, this is really just possessed, this program. I don't know what's going on. My favorite program, not to knock Notability, but my favorite program used to be GoodNotes, but then GoodNotes just started crashing a lot. And for this, like even though Notability glitches, I don't want to jinx it. Watch, this just crashes now. But Notability does kind of hold up. So there's a lot of behind the scenes stuff that goes into choosing which program to use. All right, but notice what I just established. I established that both pairs of angles here are congruent. So you see I established angle 1 is congruent to angle 3, and I established that angle 2 is congruent to angle 4. So we established ASA. So now we can make our concluding statement. We could say that triangle AED is congruent to triangle CEB. And the reason? ASA. Okay, so that is the end of the proof part, but we have to describe a single rigid motion that maps triangle AED onto triangle CEB. Now, one thing to point out again is notice that they're sharing point E, but A has to map to point C. Okay, so don't say reflection, because if you reflect this, like let's say over like this line, it would go over here. If you do a point reflection looks like that'll work. But I think the more obvious one is just do a 180-degree rotation. Okay, that if we do, something like this. Actually, let me try it like this. So if you go try that one more time. I'll go through the diagram so I could just take this whole piece out. Okay, so this, and that gonna let me rotate. Maybe if I group. All right, is this? Yeah, it's being a little stubborn. I was gonna see like to. All right, you know what? I'll just leave this for now. But basically, if I rotate this 180 degrees, you could see how like A and C are on the same straight line like this. D and B are on the same straight line. And then E is like just going to map to itself. So I would just say a 180-degree rotation about, that's point E. That got crossed out. Okay, so we'll just write this out. And we should be good. Oh, yeah, can I show the Regents Algebra 2024? Yeah, tomorrow I will be live streaming for it. But yeah. All right, cool. So rotate triangle, and we're mapping AED onto CEB. So rotate AED, and you can pick your favorite direction because 180 clockwise or counterclockwise is going to have the same effect. I'll just say clockwise because it's less writing. So about point E. Okay. So that's it. 33 conquered. Oh, finally, back to like just doing non-writing math. Not that I don't like proofs. Like I do enjoy proofs, but I don't know. I like the ones that are like really like complex. Like you have to really tackle into, dive into, and it gets a little complicated. All right. So let's just see anything popping up in the chat. All right, we still got a few people here. So once again, yeah, thank you for everyone who watched or is currently watching. But yeah, I'm sorry, I can't read. Is that Russian that I'm reading? I should get better at all the different letterings. But I will. I plan on doing Algebra 1 tomorrow, and then the following day I'm gonna do Algebra 2. So I want to make sure I cover everybody. Let me look at the region schedule. So January region schedule. Is there? Oh, they do have physics. Ooh. Physics is on Wednesday. I was playing with the idea of trying to do physics. What is the best Regents exam to study off? Thanks in advance. That is a good question. Let me think about that. So at Oliver Owens, what is the best Regents exam to study off of? I mean, Oliver, it's kind of anyone's guess, like what caliber of question they're going to put on that Regents. I think sometimes they do make January like maybe a little bit more challenging than June, but I can't remember, honestly, because I'm thinking even about the Algebra 1 Regents that I plan on doing tomorrow. And that Regents, I know, was like, I was thinking like, ooh, that was difficult. So it really depends on their mood. I don't know what inspires them to do what. I mean, I guess in some regard, like the more people that don't pass, it's like, hey, now you have to retake it. So that's like more money for the people that make the test. I'm not saying it's just purely a business, but I guess there is some, yeah, there are a decent amount of people that have to retake it. I know a lot of people, like, it depends on your school and like, like what your setbacks were and all that stuff. But yeah, I would just say do the most recent ones, but also ask questions like on these live streams and stuff. But my best advice, I guess, to prepare, like if I break character for a moment and just talk about strategy, is do a full Regents. And so the Geometry Regents is in the morning, not tomorrow, but the next day. Let me just double check the schedule so I don't make something up. Yeah, Wednesday, January 24. So I would do a full Regents, and then anything you get wrong, do a deep dive into like, what are you missing? Did you say 5 plus 5 is 12 by mistake? Or are you just like missing a theorem or a concept? So I would just, do one full Regents at least. And if you have time, do a second one. But if not, one will have to do. So yeah, I would go more recent. And I have videos on all the recent ones too. So, I mean, not to just self-promote, but if you're like, oh, I don't understand that. Like I spent a decent amount of time making sure the explanations were crisp. So it should be helpful. All right. So this is one of those questions where like we have a lot going on, but really all that matters is like the distance between the park ranger station and the lifeguard chair. Like I just find the thing like in the question itself, but of course, like I'm going to still read the question just to make sure I'm actually answering it. So they have a diagram below. The line of sight from the park ranger station is P. Okay, so park ranger station here is P, and the lifeguard chair is L. See, they define that in the beginning of the question. And they tell us that it's perpendicular, so they have these right angles here, and the first aid station is F. Okay, so even here, like first aid station, like that's going to be F. And campground is C. All right, so they just like, they gave us a word problem, but it's like one of those like word problems where I don't know, the diagram kind of does everything for you. So it's like almost like an anti-word problem. I don't know. So they told us also all the dimensions, but what is the distance? Okay, so the actual question here is to the nearest hundredth of a mile, the distance between P and L. So you could call that X or you could call it Y. Maybe I'll call it Y because it's vertical, but that doesn't matter. And notice we have a right triangle here. We know two sides and we want to find the third side. We could use the Pythagorean theorem. So I'm going to say Y squared plus 0.25 squared is equal to 0.55 squared. Okay, and then from here, I could just go like this. I could go minus 0.25 squared on both sides. All right, please don't do 5 minus 2 Like don't do something like that because these are being squared. So we can't just subtract. So we have y squared equals 0.55 squared minus 0.25 squared. And now we square root both sides. And this tells us y equals, and now we just type this in. Okay, so we're going to type in, let's see, that whole mess. All right, so ready? I'm going to clear this out. Second, x squared to pull up a square root, and I have 0.55 squared minus 0.25 squared. So to the nearest hundredth, it's going to be 0.49. All right, let's put this here. Okay, so, yeah, I could just chop it out like that. So 0.49. Okay, so to the nearest hundredth of a mile, I'll just write over here 0.49 miles. And I'll circle the answer. Okay, so that's our answer to the first part. Now they say Gerald believes the distance from the first aid station to the campground is at least 1.5 miles. So that's this distance here from F to C. Gerald is saying that that's 1.5. So what we could do here is we could just call this part here X. And they said, let's see, we're using this information from before. And for this part, I guess it gets a little bit debatable, but they told us to round this part to the nearest hundredth. So imagine here, it's going to be totally fine for us to just use this value from before. Like usually the last thing you should do is round, but here it's not going to be, a big problem. Like we found y is equal to, so I'll write that over here, 0.49. Okay, and it's miles. So that's the vertical distance here. So we could use the altitude rule now. All right, there's more than, once again, there's more than one way to do this, but the altitude rule is pretty nice. So with the altitude rule, what we're going to have is we're going to have x over the altitude 0.49 is equal to the altitude 0.49 over the other piece of this hypotenuse 0.25. Okay, so that's how that'll work. If that part is not obvious, what I like to imagine is, see how these triangles here, like this triangle and this right triangle, are not facing the same direction. Like what we could do is we could take this triangle here and we could write it like, we could draw it like this. All right, make that neater. So we draw it like this, and this segment here is 0.49, and this segment is x. So then you see how it's more obvious that it's like x over 0.49 equals 0.49 over 0.25. So if you just take this and draw it this way, it's obvious why this proportion is good. Okay, so now all I have to do is multiply both sides by 0.49. So I'll just move that over. I don't know why I feel like I should be writing inside the margins. Did they say don't write outside of that space? I guess they don't, so it's not a big deal. I feel like on some math tests I've seen that, like, don't write outside this, or minus 1,000. It's like, oh no, but I know how to do the math. Okay, so x equals, and now we work this out. Let's see. So, oh, hang on a sec. The chat has been lighting up here. Let's see. Helping my daughter left donation. Oh, thank you for the donation. I do appreciate that. At Lisa Carter. Wish I could figure out your schedule on a regular basis. Yeah, at Lisa, I live stream around the time of the Regents. I don't live stream during the week. I make videos during the week, as best as I can. The live streams I do during testing season, but I should put out a vote and see, like, would people prefer that I live stream, weeks in advance, days in advance, the night before, all the above? Like, what do people really want? Like, realistically, when are people going to check out the live streams? Because I did put a vote in way back, I want to say over a year ago, and the live streams were kind of like voted less. Like, I was at one point doing regular live streams, but I guess I wasn't getting as much traffic to them when it's like a regular part of the school year. So I started just doing them around the big test. So yeah, like I anticipate tomorrow that algebra will be much bigger. But because people need that one to graduate, like they need one math Regents, and usually that's the one they go for. But at the June section, I remember geometry being huge. So I mean, I try to get the instruction in when I can, but I like live streaming when people are like, really, really like cramming like the night before. So I could be in there to answer questions. But thank you for the donation. I really do appreciate it. Yeah, it's, I'm really like, I can't thank you all enough for being a part of this. Like I do really appreciate that the channel has grown to what it has, and the amount of people I get to interact with is just like, I still like, it really like hits me at times. Like, so thank you for being a part of this. All right. So here, now we're doing 0.49 squared. I can even take this one and square it and then divide, but whatever, 0.49 squared, because I'm multiplying it by itself, and then I divide by this. So moment of truth. This is going to work out to 0.96. Now, one thing I want to verify is if I take this value and I square this and I divide that by 0.25. Yeah, see, it's still going to be 0.96. Obviously, it's going to get us like way closer, but 0.96 either way. If we use the unrounded answer from the first part or the rounded answer, either way, we're getting 0.96. Okay, but make sure that you actually answer the question. The question was actually asking, so this, we could say here that this is 0.96 miles. The question is asking us, let me start that sentence over. Gerald believes that the distance from F to C is at least 1.5 miles. So now we just have to add those two together. Okay, so do 0.96 plus, and then we have 0.25. And this, I'll move this over, is equal to, it's going to be 1.21. Yeah, 1.21 is equal to 1.21. However, we should comment this is less than 1.5. Okay, you see this is less than 1.5. Therefore, what do we say? Gerald is incorrect. Sorry, Gerald. Gerald is incorrect. We only have to justify. Justify means show work. Okay, so show, actually, I would say show math. Or show math sounds silly. I don't know. Wow, I don't even know how I did that. That was impressive. Learned something new. All right, I would say do the math. Okay, like you do the math, and that's going to support your answer. So Gerald is incorrect. Okay, we don't have to explain and write like a paragraph here. So scared for the Regents, about to pull an all-nighter to study. All right, so at that one, pulling an all-nighter, it might be worth your time. It's one of those hit or miss things. Oh wow, Lisa Carter, thank you. I see it now. The donation, it's much appreciated. Thank you so much. I'm like just truly like yeah. I thank you so much. I get speechless when people start donating. I'm still getting used to this like whole live streaming stuff, but I really do appreciate you acknowledging me here. So thank you. But pulling an all-nighter is tricky because if you show up on like no battery, it's like you got to take a test and you're just like falling asleep at the test. You really want to have your brain power. I mean, there's definitely plenty of studies that show if you're sleep deprived, your cognitive functioning just starts to decline. Like me, I'm a little bit sleep deprived today. I didn't get a great night's sleep yesterday, and I definitely don't feel as sharp. Like that's why I'm kind of like tripping over my sentences a little bit. Like I'm not feeling as smooth. So getting that good night's sleep sometimes is worth more. In economics, so let me see if I could just add in a page here. So let me see. How do I, maybe new page? See, I don't want to butcher this whole thing. Maybe, add page. Here we go. Okay. So some economics for you. Why pulling an all-nighter might be bad. So it's called the law of diminishing returns. Is that like your effectiveness or knowledge? How about your knowledge as a function of time? Is like, let's say you study 6 hours the day before. This is how much your knowledge is going to improve. Okay, you're like, wow, I learned so much. But then you're like, you know what? The test, it's like, let's say 8 hours away. And you're like, I'm just going to study for those 8 hours. It's like the amount you're gaining after you start to like not sleep is like only so marginally better, and this might even be generous from here to here, that it's really not worth your time. But you also have to consider like this is like all you're learning, but your ability as a function of time might decrease massively because you're not sleeping. So just be aware of that I know it's like very like trendy, and don't get me wrong, I've pulled all-nighters before. Okay, yes, when I was a college student, like maybe I saved 1 or 2 papers to the very last minute, and I had to stay up all night writing that paper, and I didn't do amazing, but like I had to do it. Sometimes like I guess there is no choice, so I don't want to like say one thing and then I did another, but I know from experience that the all-nighters was like not pretty the next day. All right, but I guess if it's like truly necessary, you do what you have to do once in a while, but it's just take care of yourself. I just, don't want to see you all like crash and burn. Okay, so this question is pretty intense. 6 points. All right, this is like as bad as it gets in terms of volume. So we have a water tower, and they're telling us that it's composed of a hemisphere. So I'll try to write a color that pops. So this is the the hemisphere. Okay, and a hemisphere is half of a sphere. So for that, I'm thinking volume is 4/3 pi r cubed. This is on the reference sheet, but it's a hemisphere, it's half. So we divide all of that by 2. Okay, the middle is a cylinder. See, this piece here is a cylinder. And the volume of a cylinder is pi r squared h. Okay, and then finally, the last one is the cone. And the volume of a cone is 1/3 pi r squared h. Okay, so it's 1/3 the volume of a cylinder. So I'm just throwing that all out there because it helps to have all your formulas lined up. Because I think the first thing they want us to do is determine and state to the nearest cubic foot the volume of the water tower. Now, one of the immediate challenges that we run into is this cone. But first, I'll talk about everything else. They told us, I guess they just put it in the diagram here. Let's see. Did they tell us anything about? All right, so they told us AC, that's the radius, is 8.5. So remember, the radius is the same anywhere like in a sphere, so and a hemisphere. So if this is 8.5, then you see how like this would be 8.5 and this would be 8.5. And here, this is a cylinder. The height of a cylinder doesn't change. So if this is 25, then this is also 25. Okay, 25 feet. But the more important one, I guess, would be the height going through like this. So this is also 25. And remember, this radius was 8.5. So this is 8.5. And this is 8.5. The height here, though, wow, this is like really cool. So DE. So DE, let's say I put an X here. So to find X, wow, I can already see. So we have to find the volume of the cone, the volume of the cylinder, the volume of the hemisphere, and add it. So like these are ready to go. Like this one is ready to go. It's the cone. This one is definitely tricky. Okay, so this one requires the most attention to detail. So first, I would say something like tangent of 47 degrees is equal to x over 8.5. See, like I have a right triangle here. So x over 8.5. Okay, and then I just cross multiply. So x would be equal to, so this tells us x equals 8.5 times tangent of 47. Now for this question, I would round at the end. Okay, this is not one of those questions where they're telling us to round like throughout. We have to round the volume of the entire tower at the end. So x, I'm going to leave it unrounded. So just come over here, get the calculator. We are in degrees. Make sure you're in degrees for the whole geometry regions. So you have this, you type it in, and we get this whole mess here. Okay, so I'll just drag this over here. So x is equal to 9.115134, and they're measuring this in feet. Okay, I'll just stop there. I guess, I don't have to keep writing too much more. This is like more than enough. So now I have everything I need to plug in and find the volume. So we have the volume of the cone is 1/3 pi r squared h. You see how the radius is the distance from here to here, is the 8.5. So the volume of the water tower, so I'll just say here, like the volume equals, so let me just make that neater. That one didn't come out nice. So the volume equals, so we have 1/3, we'll do the cone first. That was the most annoying one. 1/3 pi times the radius is 8.5. And the radius is being squared. Times the height is this mess, 9.11513, like this. Okay, plus, and then we have pi r squared h. So you see the cylinder, the radius is still 8.5. So you have pi times 8.5 squared times the height is 25. Okay, and then plus the volume of the hemisphere is 4/3 pi, and then the radius is 8.5. It's being cubed. Now we divide that whole mess by 2. Okay, and the volume is to the nearest cubic foot. All right, so that was a whole lot to write. Okay, yeah, this question was like really, it was kind of cruel. I can't imagine like a lot of people got full credit on this, but I guess for that reason, it's good to see. Okay, because then the next part is fun, just not making a typo. Like, how do you type this in the calculator? So that I'm going to show you too. How do you type this in nicely? All right. Oh, okay. I'm sorry. I realized I could celebrate. I could click and put hearts too, celebrating. But thank you. Yeah, thank you again, at Lisa Carter. I appreciate that. Yeah, I'm still like, yes. I have to get more comfortable with these, like the function of like how to work everything here. All right, so I'll show you how to type this nicely. So 1/3. I could just go. I could just put 1/3 in parentheses like this as 1/3. I don't even need the parentheses, but it gives me peace of mind. Times pi times 8.5 squared times that whole mess. I'm glad I only have to write that once. Okay, and we have plus pi times the second piece after the 9.11, whatever, is pi times 8.5 squared times 25. And then we have plus. Now this one's messy, so I'll press alpha y equals enter to pull up a blank fraction. And we have 4/3 pi. So I'll put the 4/3 pi. I'll put the 4/3 in parentheses, then pi. Then I'll put 8.5 to the third in parentheses. So 8.5 parentheses closed, then to the third. And then all divided by 2. And press enter. And this is the value we need. Okay, so I'm just going to borrow this because that's definitely a bit to remember. And this tells us the volume to the nearest cubic foot. Okay, so the volume to the nearest cubic foot is going to be 7650. I don't know if it's the pen I'm using or if it's the program. My computer's lagging. It could be a million things. All right, so this is part of the credit here. And now for the last bit of the credit, the water tower was constructed to hold a maximum of 400,000 pounds of water. If water weighs 62.4 pounds per cubic foot, can the water tower be filled to 85% of its volume and not exceed the weight limit? Okay, so first I would find 85% of the total volume. So take the 7650 cubic feet and multiply by 85%. Just know 85% is 85 out of 100. And that's the same thing as 0.85. So I would just multiply this first by 0.85. And that's going to tell us how many cubic feet of space we have. So this, we'll just pull up the calculator. So we're taking 7650. And we're going to multiply by 0.85. Okay, we get this value here. So I just want to see, because we're using the value from the previous answer. So 6502.5. Okay, so 6502.5 cubic feet. Now, I like to write the units personally because it helps me understand what's going on. But if we're only filling up 85% of the water tower, then that means that we're only using this much space. So now we consider the density coming up. I'm sorry, someone's just randomly doing fireworks outside. All right. I guess they're celebrating you all studying for the Geometry Regents. So let's see here. We have 6502.5 cubic feet. And we're multiplying by the density is 62 pounds. I'm sorry, 62.4 pounds per cubic foot. So cubic foot means feet to the third. So once again, I like to write the units in the question so that we could see the units canceling. And now I just multiply this value by 62.4. Okay, so let's go ahead and do that. So this times 62.4 gives us this. Okay, so there's our mystery value here that we need. So it's 405,756, and remember, it was pounds. So now let's think about the question. If the water weighs this, blah, 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 can it be filled and not exceed the weight limit? And we say no. Okay, so no, the water will exceed. Because, yeah, that's more than 400,000, so the water will exceed the limit. Okay, if we have to justify, I mean, I could just sprinkle this in. If I just want to write it because, I could say because that value, 405,756, is greater than 400,000. Okay, so that's just, yeah, our justification. All right, very good. So that's the 6-point question. Now we graduate to the final question. Okay, this is the last question that is on this Regents. And then I'll just kind of do open Q&A and answer what I can. All right, so here we have a coordinate plane, and the use of the set of axes on the next page is optional. All right, I mean, I'll just take a screenshot of this and use it more than once, because I always tell my students, like, they should absolutely be using, the pictures that they give you. Okay, so prove that triangle RST is a right triangle. So R is at 1, 2, 3, 4, 5, 6. Let me make this bigger. So 1, 2, 3, 4, 5, 6, negative 1. So I recommend that you plot this. If you just really get this, though, and you want to do this without plotting it, then, like, yeah, if you're that comfortable, then go ahead. But I recommend you do this. So negative 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Okay, so this is T. And now, this is what we have. Here's our triangle. Now, I like to draw it because it makes it obvious where the right angle is. And I think we can see here the right angle is at angle S. Now, if I'm trying to show that this is a right triangle, there's a few ways that we could go forward with this. We could target the slope. We could target the length of the 3 sides and show that they satisfy the Pythagorean theorem. So, I don't know, maybe we want to go the slope route. So here, now let me just drag this over. I could find the slope, and I'll just even group this. Just so, oh, whoops, that didn't help at all. I was trying to group it all to this. Can I group that to 1? No. All right, no big deal. I tried. So here, whoops, let me try that one more time. Okay, I just want to block out the question. So I can find the slope of line segment ST. And remember, the slope formula is y2 minus y1 over x2 minus x1. Okay, I could also use rise over run. So I'll show both ways. If I do the difference of the y values, I get 6, I'm writing first, and then minus negative 4, divided by negative 5 minus 1. And this works out to 10, because I have 6 plus 4 on top. Minus minus goes plus over this. And this is equal to, if you divide top and bottom by 2, you're going to get negative and then 5/3. Okay, just know with fractions, like just a side note, this is the same thing as this, and that's the same thing as negative and then 1 over 2. Okay, you could write the negative in front like this. That's also fine. So there's 3 ways to write it. That's why that negative, I just throw it up there. But sometimes that throws students off. Like, wait, why? Like, how did you do that? Like, the negative is flexible. Okay, So that's the slope of ST. Now the slope of SR, make that a little bit neater. So I just need this pen to hang on a little bit longer. So the slope of SR, let's say I use rise over run. I could go up 1, 2, 3. So my rise is 3 and my run is 1, 2, 3, 4, 5. Okay, so you could just go count the rise over run, and that also gives you the slope. Now notice that these numbers are opposite reciprocals. Okay, so I could say here, since the slopes of segment SR and segment ST are, let me make that, space that out a little bit, are opposite reciprocals. So opposite reciprocals, we could write our conclusion here. That tells us that segment SR is perpendicular to segment ST. Okay, so these two line segments are perpendicular, which then means I could say, so angle S is a right angle. So our goal, make sure we actually prove it. Prove that RST is a right triangle. I could say triangle RST is a right triangle. I'll abbreviate because it has a right angle. Okay, so that proves it. That's plenty. State the coordinates of P such that quadrilateral RSTP would be a rectangle. So you could probably just start imagining, like, if this is the point over here, this one you could probably just eyeball. Like, where would it go? Like, maybe here, but like, no. Like, maybe here. No, like, this one's looking good. So, like, somewhere in this neighborhood. But if you want to be precise, we use rise over run. So I want to count, how do I get from S to T? I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going up 10. And I'm going over, let's count, 1, 2, 3, 4, 5, 6. So now, you see how I did that from S to go to T? A rectangle, opposite sides are equal in measure. So I'm going to do the same thing from R to get to point P. I'm going to go up 10. I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to go over 6. 1, 2, 3. That was here. 3, 4, 5, 6. Okay, so let me move that slope formula out of the way. Oh, whoops. Oh, wow, that's all connected. It's like a bit of a fail. Maybe if I just erase this. I don't think we need the slope formula anymore. Okay, so this brought us here. All right, and you could even see if I connect this, like, that's why you should absolutely graph this, because, like, seeing is believing. I'm like, yeah, that's definitely a rectangle. Like, I'm okay with that. So we just have to state the coordinates. We don't have to explain what we did. So I'm just going to say P is at the point 0, 9. Okay, now, if you want to be, like, even more precise, just know that the coordinates of S, if I were to write them here, are 1, -4. And the coordinates of T are -5, 6. So you see, if I pay attention to the Y values, to get from -4 to 6, I have to go up 10. Okay, and if I have to go from 1 to -5, that's where the -6 is coming from. We're going left 6. So here I could use that idea. R is at 6, -1. And you see, if I go up 10, that means I'm targeting the Y value. And let's make it match up color code. So my Y value is -1. So when I get to point P, like, how do I know point P is for sure at the point 0, 9? Is I, once again, target the Y value. We're going up 10. -1 plus 10 is 9. And this is just not agreeing with me right now. Okay, so here we go. And then the X, and we're going to the left 6. So 6 minus 6 would bring me to 0. So you see, like, that's like a faster way of knowing, like, that this is going to be good. But either way, And now we have to last prove that our quadrilateral RSTP is a rectangle. So there's a few ways that we could do this. Let me think about what we have so far. We found the slope of ST is -5/3. So what we could do is we could find the slope of PR and show that it's the same. Okay, so we could prove that this line segment here is parallel to this line segment. And then we already have also that this slope here is 3/5. So we could find the slope of this line segment PT and show that it's also 3/5. So if we show that both pairs of opposite sides are parallel, that would make this a parallelogram. And since we already established that angle S is a right angle, a parallelogram with a right angle is a rectangle. Okay, so now we just kind of summarize it all together. I'm gonna borrow what we have here though. Okay, so we're gonna borrow, let me zoom out so I don't have to, remember anything here. So we have the slope of ST was equal to -5/3. And then we have the slope of SR. So we have the slope of SR was equal to 3/5. Okay. So now I'm just going to move this into a better spot. Whoops. Oh, wait, edit, redo. I want that back. Okay. Yeah, I didn't feel like redrawing that. Okay, so let me just move this over here. So now, see how we found the slope of ST and SR? Now I'm going to find the slope of PR. Okay, so the slope of PR, is equal to, and if we look here, the slope of PR, I could just use that rise over run. I'm going up 10 to the left 6 to get from R to P. So up 10 and to the left 6, see how that simplifies to -5/3. Okay, and if we pay attention to what just happened, these are equal to each other. All right, and now we found the slope of PR. We could find the slope of PT. So the slope of PT is equal to, and for PT, see I'm going up 1, 2, 3 over 1, 2, 3, 4, 5. So my slope is 3/5. But now think about what we just established. So I'm going to just borrow this because I don't feel like actually like scrolling back and forth 500 times. So forgive the, I guess like how it could look a little nicer, but it's really just there to guide our writing. Okay, so now we're ready to summarize here. What we have is, since the measure of ST is equal to the measure of, since the slope of ST is equal to the slope of PR, they're both equal to -5/3. This means, so I'll put a forward arrow like this. This means that ST is parallel to PR. Okay, so ST is parallel to PR. I could even like say RP if I want the letters to be going in the same order, like ST and PR. It doesn't matter though, either way. And now I could also say, since the slope of SR is equal to the slope of PT, and that's equal to 3/5. This tells us that SR is parallel to TP. Okay, or PT, but either way, once again, it's fine. Okay, so now that we have this, let's think about what we just established. We just established that both pairs of opposite sides are parallel. So I could say that RSTP is a parallelogram. Okay, because both pairs of opposite sides are parallel. All right, so that part is done. But now think about what we said before. We said that angle S is a right angle. So from before, once again, so angle S is a right angle. So now we just summarize all this. So therefore, our STP is a rectangle right? And because we have, so now I'll get rid of this picture. That picture doesn't look so nice anyway. Okay, so, oh, that's annoying. I was writing over. Is there a way for me to borrow all this? No. All right, let me do surgery here. Maybe if I delete it over here. Oh, that was a bit of a fail. All right, I apologize about that. That's why like when I do these not live, like I could really control the editing, but live is like kind of annoying like when this type of stuff happens. All right, so this is a rectangle because a parallelogram with a right angle is a rectangle. Sorry for the terrible flow here, but that's, yeah, pretend this is gone. All right, and that's it. Okay, that is the June 2015 Regents. All done. So yeah, to anybody who stopped by, first off, just thank you. And let me see how many people we have going right now. Yeah, I think, yeah, we made it to the end here of the Regents. But yeah, to anyone who stopped by, just once again, thank you so much for the support. Remember, I will be back for Algebra 1 tomorrow. So if you wouldn't mind help me spread the word. I have to do a better job of advertising. I probably should make a YouTube short. My wife told me like, oh, make a YouTube short saying that you're going to do this. But yeah, I forgot to do it. So that's whoops. But we'll see. Tomorrow should be exciting. Today, I really do appreciate, the people who stopped by. Thank you. And thank you for the comments. Again, at Lisa Carter, thank you so much for the tip. I do appreciate the support. But good luck to anybody taking this Regents. Good luck to anyone who's taking final exams. And thank you. And have a good night.